Hello students, welcome to Study Out. This question is from Chemistry, chapter Thermodynamics. Calculate the enthalpy change on freezing of 1 mole of water at 10 degrees Celsius to ice at minus 10 degrees Celsius. Here enthalpy of fusion is given 6.03 kilojoule per mole at 0 degrees Celsius. Molar heat capacity of water at liquid state and in the solid state or in the ice is given. Based on this information, we have to find the enthalpy change. So let's understand this question. In this figure, we take four phases. In these phases, water at 10 degrees Celsius will change to ice at minus 10 degrees Celsius. So first this water, it's at 10 degrees Celsius, will change to 0 degrees Celsius. Means here the temperature is changing, but the state of water remains the same. It means it's in the liquid state. Now when this water will change to ice, during that time temperature remains the same. Temperature is not changing. Now after that, this ice at 0 degrees Celsius will change to ice at minus 10 degrees Celsius. So let's understand here what we can do. When the water at 10 degrees Celsius will change to water at 0 degrees Celsius, there is a certain loss of energy. So we can represent it as Q1. And this Q1 we can find by using the formula NCP delta T. This formula we are going to use it here. Now when the water at 0 degrees Celsius will change to ice at 0 degrees Celsius, again heat is released. Let's consider this is Q2. And Q2 is equal to minus of delta fusion enthalpy. Why it is minus? Because in the question we have the information about the enthalpy of fusion. So when enthalpy of fusion takes place, when any solid will convert to liquid, during that time the enthalpy is our positive because we need to supply the energy. Then solid will convert to liquid. But in this case, here water is converted to ice. In this case, heat will be released. Whatever heat is absorbed by solid to liquid, now the same amount of heat will be released when water is changing to ice. So during that time, this is what? This is the freezing. This is enthalpy of freezing. So enthalpy of freezing is negative of enthalpy of fusion because it's in the exothermic reaction. So similar way, we can say that this enthalpy of freezing is equal to negative of enthalpy of fusion. Now this ice at 0 degrees Celsius will change to ice at minus 10 degrees Celsius. So in this case, we can consider it is Q3 and it is equal to NCP delta T. So this Cp we can consider as dash because it is for ice, and this Cp we can consider for water. So total enthalpy change is nothing but the sum of all the enthalpy. So Q is equal to Q1 plus Q2 plus Q3. Separately we can find Q1, Q2 and Q3 value and substitute it here. So Q1 is equal to N into Cp delta T. N is what? That's the mole of water. In the question it is given it's 1 mole. So we substitute 1 mole. Cp for water is 75.3 joule per mole Kelvin. So here this is 1, this is 75.3 into change in temperature. Initially it was 10 degrees Celsius and finally it is 0 degrees Celsius. So change in temperature is 0 minus 10 equal to minus 753 joule. So this is the value of Q1. Similarly, Q2. Q2 is equal to negative of enthalpy of fusion. And enthalpy of fusion is here given as 6.03 kilojoule. So kilojoule we can convert to joule. So it's equal to 6030 joule. So this is the value for Q2. Now we have to find Q3. Q3 is equal to NCP dash delta T. So here mole is same, whatever the mole of water, same mole for ice, so it is 1. Cp for the ice is 36.8 joule. You can substitute it here, 36.8 joule. And what is change in temperature? Final is minus 10 and initial is 0. So final minus initial. Minus 10 minus of 0. It's equal to minus 368 joule. So this is the value of Q1, Q2 and Q3. Now we can add all of it. So Q is equal to Q1 plus Q2 plus Q3. Q1 value is 753. So minus 753 joule plus minus Q2 is 6030 joule and Q3 is minus 368 joule. So if we add all of it, it will be equal to 7151 joule or minus 7.15 kilojoule. So this is the answer of this question. If you have any doubt, you can mention it in the comment box. I will try to resolve it. Thank you so much.